Crash Course Instrumentation presents Episode 60, Parallel Circuits, Failures, Power and Protection. Cold open. 3 failure modes decide whether a parallel circuit shrugs or smokes: open branches, shorted branches, and a sagging source. Learn to spot each in seconds and fix the right thing first. Quick recap: parallel versus series. Parallel. 2 common nodes shared by all branches. The same voltage appears across every branch. Branch currents add at the source. Equivalent resistance goes down as you add branches. Series. 1 path for current. The same current flows through every part. Voltage drops add up. Total resistance goes up as you add parts. Failure mode number 1. Open branch. An open branch is a broken path, so its current falls to 0. Other branches still see the source voltage and usually keep working. Result: total current drops and the equivalent resistance increases. Field telltales: one device dies while others remain normal. Source current falls. No fuse blows. Failure mode number 2. Shorted branch. A shorted branch is nearly 0 ohms and tries to pull a very large current. With correct protection, the branch, fuse, or breaker trips quickly. If protection is missing or too large, the source voltage sags and everything dims, or conductors overheat. Field telltales: several loads dim or quit at once. Supply voltage under load is much lower than open circuit. A hot smell or a tripped device appears. Failure mode number 3. Sagging source and wiring drops. Nothing may be broken. The source or long wiring just can't deliver the current. Internal resistance makes source voltage fall as total current rises, so every branch underperforms together. Quick test: measure the source open circuit, then measure under load. A big drop points to the source or the wiring, not the loads. Branch power and total power, why heat happens. Power equals voltage times current. In parallel, each branch has the same voltage, so branch power scales with its branch current. Total power is the sum of branch powers, which is why adding branches raises the total draw and the heat that must be managed. Design tip: choose parts with adequate wattage ratings and give hot parts room for airflow. Protection that matches the physics. Protect each branch for its own expected current, not the sum of all branches. Pick a wire gauge that safely carries that branch current and consider temperature. Place protection close to the source to limit fault energy. Aim for selective clearing. A faulted branch opens while the healthy ones keep running. Always follow your local code requirements. Measurement pitfalls: save your meter. Voltmeters go across a component or branch. Ammeters go in series with a branch, never across the source, or the meter becomes the short. Clamp meters are ideal for branch current. Loop around one conductor, never both. For DC, use a Hall effect clamp. For AC, a standard clamp works. Worked example in words: a 12-volt source feeds 3 branches, 120 ohms, 60 ohms, and 30 ohms. The shared voltage is 12 volts on each branch. Branch currents: 12 over 120 is 0.10 amp, 12 over 60 is 0.20 amp, 12 over 30 is 0.40 amp. Total current adds to 0.7 amp. Equivalent resistance is source voltage divided by total current. 12 over 0.7, 17.1 ohms. Total power is voltage times total current. 12 x 0.70, 8.4 watts. Branch powers are about 1.2 watts, 2.4 watts, and 4.8 watts. Real-world gotchas. Parallel LEDs rarely share current perfectly. A small series resistor in each LED branch prevents one LED from hogging current. Parallel heaters or motors may run fine until a branch shorts. Correct per-branch fusing prevents a total blackout. In control cabinets, hidden shared returns can create surprise parallel paths and phantom currents. Route and label returns clearly. History bite: why homes aren't wired in series. Early city lighting used series arc lamps. Bright but unforgiving. If one lamp opened, the whole string went dark. Edison's practical systems adopted parallel distribution, so each lamp kept full voltage and could work independently. That choice scaled from the 1880s into modern neighborhoods. Branch circuits with local protection are parallel at their core. Recap: Opens kill one branch. Shorts threaten the whole network. A weak source dims everything. Power adds by branch. Protect each path for its own current and place protection near the source. Measure in the right place. Across for voltage, in series for current. And troubleshooting gets faster and safer. Outro. If this helped you troubleshoot faster, subscribe so you never miss the next Crash Course Instrumentation episode. Special thanks to Tony Coupault and the open source community for making world-class learning freely available to everyone.